Hey guys, it's Danny here from Disrupt Tutoring, and as always, it is a pleasure to join you. In this video, we're going to do a question from the November 2019 Grade 12 Physical Sciences Paper 2. This question deals with a galvanic cell represented by the galvanic cell notation given. In this notation, the anode half is always listed first. So the first question asks us to name the components of the cell represented by the two vertical lines in the cell notation. So these vertical lines represent the salt bridge, which connects the two half cells and allows for the transfer of ions between the two half cells. Okay, then the next question asks us to state two standard conditions applicable to the tin half cell. And the standard conditions refer to the conditions under which the standard electrode potentials are measured. So these conditions are a temperature of 298 Kelvin, or 25 degrees Celsius, and a concentration of 1 mole per dm cubed for the solution. Okay, so then the third question asks us to give one property of platinum that makes it suitable for the use as the electrode for the tin half cell, and this can be any one of the options. It is solid, it is inert, or it is conductive. Okay, then moving on, the next question asks us to define the term cathode. So the cathode is the electrode at which reduction occurs. And then the very next question asks us to write down the symbol for the cathode in this reaction. So in the cell notation, the cathode half cell is written second. And in this case, the electrode given is platinum. So the symbol for the cathode would be PT. Okay, and then the next question asks us to write the chemical equation that represents the reduction half reaction. So this reaction takes place at the cathode, and the cathode is listed second, so that involves the tin 4 plus ions and the tin 2 plus ions, and we can find the equation involving those two on the table of standard reduction potentials. So here it is listed at the bottom, so we can say that the equation that represents the reduction half reaction is SN4 plus 2 electrons goes to SN2 plus. Okay, and then the last few questions, 6.7 asks us to define the reducing agent. So a reducing agent is the substance that is oxidized and is therefore the substance that donates electrons. And we're asked to write down the symbol of the reducing agent. So the reducing agent is the anode, which is written first, and in this case, the anode is zinc, so the symbol for the reducing agent is Zn. The next question asks us to determine the initial cell EMF. So this is found on the table of standard reduction potentials once again, and using this equation, so the potential of the cell is equal to the potential of the cathode minus the potential at the anode. So for the cathode, we need to use the potential for the reduction half reaction because reduction occurs at the cathode, and for the anode potential, we need to use the potential for the oxidation half reaction. So we can find those two. Here is the equation that takes place at the cathode, and here is the one that takes place at the anode. So we can now write down this equation. So that means that the cell EMF is equal to 0.15 minus 0.76. Okay, so this is the reduction half reaction, and this is the oxidation half reaction occurring at the cathode and the anode respectively. And that gives us a cell EMF of 0.91 volts. Okay, then the last question asks us how the initial cell EMF will be affected if the concentration of the Zn2 plus ions in the anode half cell is increased. So the standard electrode potential for Zn2 plus, so this potential right here, is measured at a concentration of 1 mole per dm cubed. So if the concentration of these positive ions in the solution were to be increased, fewer zinc atoms would be oxidized and there will be fewer electrons transferred, which will overall decrease the cell EMF. Okay? So before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.